Hello and welcome. Go ahead and find a position that feels truly comfortable for you. Lying down, perhaps, with your hands resting gently by your sides. Let your shoulders fall away from your ears. Take a slow, deep breath with me, in through your nose, filling your lungs completely. And now, a long, slow exhale, letting all the tension of your day just drift away like stardust, scattering gently into the peaceful darkness. Let's take one more, a deep cleansing breath, and a slow, soft release. There is nothing for you to do right now, nothing to solve, nowhere to be. There is only this moment, this quiet space we will share together. Tonight, we will drift. We're going to float on a gentle current of time, back through the vast, silent expanse of our universe's history. Our vessel for this journey is an eye of gold and mirrors, a magnificent creation called the James Webb Space Telescope. It is our window to the very beginning of everything. This journey is designed to lead you to a place of deep relaxation, a place of quiet wonder, and peaceful, restorative sleep. Let the gentle sounds and a calm voice be your companions as we witness the birth of the earliest galaxies and float past ancient black holes. There is no need to hold on to any thought. Simply allow my words to wash over you as you begin to drift. Let the journey begin. First, let's broaden our perspective. I want you to imagine something. Hold your hand up towards the night sky, as if you could touch the stars. Now, picture a single grain of sand held between your thumb and forefinger at arm's length. How much of the sky does it cover? A tiny, seemingly insignificant patch, a dark square against an endless tapestry. Now, imagine pointing a telescope at that tiny patch of darkness. Not just any telescope, but the most powerful eye humanity has ever opened to the cosmos. And you wait. You let the telescope stare, unblinking, gathering light for hours upon hours. What do you see? Not darkness, not a few stray stars. You see a universe. In that single, tiny patch of sky, the James Webb Space Telescope reveals not hundreds, but thousands of galaxies. Thousands of glowing islands of light, suspended in the deep. This is what astronomers call a deep field image. Try to let that sink in. Not 1,000 stars, but 1,000 galaxies. Each one of those specks, those smudges of light, is a city of stars. Some are like our own Milky Way, with hundreds of billions of suns. Others are smaller or larger, but each is a vast metropolis of light and matter. And within each of those galaxies, there are billions upon billions of stars. And around many of those stars, we now know there are planets, worlds of rock and ice and gas, an almost unimaginable number of worlds, all contained in a view that was hidden within a tiny speck of sky. Almost every direction you look, every grain of sand-sized patch of the sky, is typically just as full. The universe is not empty space dotted with lights. It's a near-infinite sea of galaxies, stretching in all directions, as far as we can possibly see. There's a profound peace in this perspective. Our own world, our own lives, our own worries, they are but a tiny, fleeting part of this immense and ancient cosmos. And tonight, we are not bound to this one small corner. We are free to explore it all. As you lie here, feel yourself becoming lighter. Feel the weight of the day lifting as your sense of scale expands. You are a quiet observer, a silent traveler, about to witness the grandest story of all. Let your mind be still, and let the universe reveal itself to you. Our journey begins in earnest as we drift into one of these remarkable images. We are floating now before Webb's first deep field, an image centered on a galaxy cluster known as SMACS 0723. It is a celestial masterpiece, painted with light that is billions of years old. Let your eyes, your mind's eye, drift across the scene. The first thing you might notice are the brightest points of light. They aren't galaxies, they are stars. Much closer to us, Like lamps on the shore of a vast ocean, they shine with a distinctive, sharp, 8-pointed glow. This is a signature of the Webb Telescope, a beautiful artifact created by light bending around its hexagonal mirrors. These are our local stars, stars within our very own Milky Way galaxy, standing as sentinels at the edge of our deep space vista. Now, let your gaze drift past these foreground stars, deeper into the image. Towards the center, you can see a collection of bright, white, and golden-hued galaxies. They look smooth, like glowing pearls. These are the members of the cluster itself, SMACS 0723, a gathering of galaxies bound together by their immense, shared gravity. They are located so far away that the light we see from them tonight began its journey around 4.6 billion years ago. That light has been traveling through space for about as long as our own planet, Earth, has existed. Let that thought settle. As you breathe in, imagine that ancient light, completing its long pilgrimage, finally arriving here, in this quiet moment, for you to see. Feel the stillness of this image. The galaxies hang suspended in the blackness, like jewels on velvet. The bright, white, elliptical galaxies at the center are the elders of this cosmic city. They are massive and have long since settled into their smooth, rounded shapes. They are the anchor of this region of space, their incredible mass shaping everything around them. As we float here, surrounded by the quiet hum of the cosmos, we can feel the immense gravity of this cluster. It is a quiet, invisible force, but its effects are profound. This cluster is more than just a beautiful collection of galaxies. It's a lens, a cosmic magnifying glass, prepared for us by nature itself, that will allow us to see even further, even deeper into the past. Just relax. Let the gentle pull of gravity, both here on Earth and in the depths of space, hold you in a safe and peaceful embrace. Let's drift closer to the heart of the SMACS 0723 cluster. The combined mass of these galaxies, along with the invisible scaffolding of dark matter that surrounds them, is so immense that it literally bends the fabric of space-time. Just as a glass lens bends light to magnify an image, this cluster's gravity bends and magnifies the light from galaxies that lie far, far behind it. This phenomenon, predicted by Albert Einstein over a century ago, is called gravitational lensing. Now, allow your attention to settle on the strange and beautiful shapes that populate the image. You can see them clearly. Long, glowing arcs of orange and red light, stretched and curved as if painted by a celestial brush. These are not strange, stretched-out galaxies. These are the distorted images of normal galaxies, galaxies that are billions of light-years more distant than the cluster itself. They would be far too faint and too small for us to see, were it not for the cluster acting as a natural telescope. Look closely at the most prominent orange arcs to the left and right of the central bright galaxy. They appear as near-perfect mirror images of each other. That's because they are. You are seeing the same distant galaxy, its light bent around the cluster along two different paths, arriving at our telescope as two distinct, mirrored images. It's a trick of light and gravity, a cosmic mirage that reveals a deeper truth. Webb's incredible resolution allows us to see not just the arc, but the bright core of the galaxy within, filled with stars, and even tiny, orange star clusters along its edges. There are other fainter arcs scattered throughout the image, each one a phantom of a galaxy from the dawn of time. Some are stretched into long, thin lines. Others are warped into curious, almost unrecognizable shapes. It's a gallery of cosmic ghosts, their light magnified and delivered to us by the gentle, persistent force of gravity. One lensed galaxy, nicknamed the Sparkler Galaxy by astronomers, is so perfectly magnified that its internal star clusters are revealed in crisp detail, mirrored from top to bottom. It's a tiny, perfect jewel box, opened for us by this cosmic lens. There's no need to understand the physics completely. Simply appreciate the beauty of it. The universe itself is providing us with a tool to peer even further into the past. Gravity, the force that holds you gently in your bed, is the same force that on a cosmic scale bends space and time itself, allowing us to witness wonders that would otherwise remain forever hidden. Let this thought soothe you, the interconnectedness of it all, from the smallest atom to the largest clusters of galaxies. Everything is gently, quietly connected. As we continue our serene drift, let's pause and reflect on the most magical aspect of this journey. We aren't just traveling through space, we're traveling through time. Light, though it seems instantaneous to us in our daily lives, has a finite speed. It's the fastest thing in the universe, but the universe is almost impossibly vast. When light travels from a distant object, it takes time to reach us. The light from our own sun takes 8 minutes to reach Earth. The light from the nearest star beyond our sun takes over 4 years. And the light from the galaxies in this deep field, it has been traveling for billions of years. This means we aren't seeing these galaxies as they are today. We're seeing them as they were when the universe was young. We are looking at a photograph of the distant past. The farther away we look, the further back in time we see. But there's another effect at play, one that the James Webb Space Telescope was specifically designed to see. The universe is expanding. Ever since the Big Bang, the fabric of space itself has been stretching, carrying galaxies away from each other. Imagine the light from a very distant galaxy, beginning its journey towards us billions of years ago. As that light travels through space, the space it's traveling through is itself expanding. This expansion stretches the waves of light, making them longer. For visible light, this shifts it towards the red end of the spectrum. This phenomenon is called redshift. The farther away a galaxy is, the faster it is moving away from us, and the more its light is redshifted. For the most distant galaxies, their light has been stretched so much that it's no longer visible to the human eye. It has been stretched all the way into the infrared part of the spectrum. This is where the James Webb Telescope becomes our guide. It is an infrared telescope, tuned perfectly to see this ancient, stretched, redshifted light from the dawn of time. The tiny, faint, reddish specks in this deep field image are some of the most distant objects ever seen. The light from some of them has been traveling for over 13.5 billion years. Think of that. Our universe is about 13.8 billion years old. This ancient light began its journey when the universe was just a toddler, less than 500 million years old. It has traveled across the expanding cosmos, past untold generations of stars, past the formation of our own galaxy, past the birth of our sun and earth, to finally, at this very moment, enter the golden eye of our telescope and be seen. Let yourself feel the poetry of that. You are resting in a cascade of photons that are among the oldest things you will ever encounter. Each one is a messenger from a lost epoch, a time when the universe was just beginning to awaken. Breathe in and breathe out, letting the deep, ancient peace of this light settle over you. Let's go back to the very beginning. Using the power of Webb's vision, we can now drift even further back in time, past the great clusters, past the well-formed spirals, to the era known as the cosmic dawn. We're seeking the very first galaxies to ever form. As we adjust our view, focusing on the faintest and reddest of smudges, a new picture emerges. The universe here looks very different. Gone are the majestic, sprawling spiral galaxies like our own Milky Way. Gone are the smooth, serene elliptical galaxies. Instead, we see a cosmos filled with small, clumpy, and irregular structures. They look almost chaotic, like fragments of light scattered across the dark. These are the infant galaxies, the first cities of stars, just beginning to assemble themselves in the young, dark universe. They are the building blocks of everything that would come later. Recent deep surveys by Webb have cataloged thousands of these early galaxies, showing us a dramatic transformation over time. The most distant galaxies of the early universe appear irregular, with intense and active star formation, while those closer to us in time have settled down, developing the organized structures we're familiar with. Let your mind drift among these primordial islands of light. They are not yet grand, but they are vibrant. Webb's sharp, I can resolve bright, blue-white clumps within them. These are massive, brilliant star clusters, nurseries where the first generations of stars are being born in a furious blaze of glory. Imagine the scene: vast clouds of pristine hydrogen and helium gas, the raw material of the cosmos, collapsing under their own gravity, igniting into the very first suns. The light from these first stars illuminated the universe for the first time, ending the cosmic dark ages. We are witnessing that moment. We're seeing the first tentative brushstrokes of the cosmic masterpiece. Some of these ancient galaxies are surprisingly bright and large, even at such an early stage, challenging our theories of how quickly they could have formed. A recently confirmed galaxy, Jade's GZ14-0, is seen as it was just 290 million years after the Big Bang, yet it is remarkably luminous and over 1/600 light-years across. Its existence suggests the rapid, early formation of massive galaxies was possible. There are even stranger discoveries. Astronomers have found objects informally nicknamed platypus galaxies because they combine features that don't seem to belong together. They can look tiny and point-like, like a star, but their light reveals the signature of star formation typically seen in a much larger galaxy. These celestial oddities suggest that the early universe may have been more flexible and creative in how it built galaxies than we ever imagined. Allow yourself to float in this nursery of creation. It's a hazy, simple, and yet beautiful place. A universe slowly waking up, assembling itself piece by piece, star by star, galaxy by galaxy. There is a gentle, unhurried rhythm to this process, an epic of construction playing out over billions of years. Feel that slow, cosmic rhythm. Let it guide the rhythm of your own breath as you sink deeper and deeper into a state of rest. Our journey can take us even deeper. For decades, our most profound view of the early universe came from the Hubble Space Telescope. Its famous ultra-deep field image was, for a generation, the benchmark of cosmic exploration, revealing a zoo of distant galaxies in a patch of sky once thought to be empty. Now, with the James Webb Space Telescope, we can revisit this classic, hallowed ground. Let's turn our attention to that same patch of sky, but now, we see it through Webb's powerful infrared eyes, and the universe, once again, expands in its breathtaking complexity. Where Hubble saw thousands of galaxies, Webb sees even more. New, fainter, redder galaxies appear out of the darkness, like writing in invisible ink, being revealed by a special light. The image becomes even more crowded, even richer, with history. It's as if we were looking at a photograph that was slightly out of focus, and suddenly, a sharper lens brings countless new details into view. One of Webb's most ambitious projects in this region is the MIRI Deep Imaging Survey, or MIDIS. Using its mid-infrared instrument, Webb stared at this patch of sky for nearly 100 hours with a single filter, producing one of the deepest views of the universe ever obtained. In this tiny area, Webb revealed more than 500 sources of light. Hundreds of these are extremely red, suggesting they are either shrouded in thick dust or are ancient, evolved systems with mature stars that formed very early in cosmic history. The comparison between Hubble and Webb isn't one of competition, but of a beautiful continuation. It's like a great explorer passing the torch to a new generation, equipped with better maps and tools. Every time we build a more powerful eye to look at the sky, the universe rewards us by revealing that it is even more grand, more populated, and more mysterious than we ever dreamed. This constant unfolding of the cosmos can be deeply reassuring. It suggests a universe of infinite possibility, of endless horizons. There's always more to see, more to learn, more to wonder at. This process of discovery is a gentle one. It doesn't happen all at once, but in quiet, patient steps. First Hubble, and now Webb, each peeling back another layer of the cosmic mystery. Let this gentle unfolding mirror your own journey into sleep. There is no need to rush, just a slow, gradual release into a deeper state of peace, layer by layer, until you are fully at rest. Breathe slowly and drift on. As we linger in this new, deeper view of the cosmos, let's take a gentle tour of the colors. The colors in these images are not what our eyes would see. They are representations of different wavelengths of infrared light, each telling a different story about the galaxy it comes from. Let your mind's eye drift towards the galaxies that glow with shades of blue and cyan. These are often the galaxies that are relatively closer to us. Their light is less redshifted, and they are typically less shrouded in cosmic dust, allowing the brilliant blue-white light of their young, hot stars to shine through clearly. They are the vibrant, youthful members of the cosmic neighborhood. Now, let's shift our focus to the galaxies that glow in soft shades of orange and deep, warm red. These are the galaxies with stories to tell. The red color can signify many things. It may mean the galaxy is incredibly distant, its light stretched by cosmic expansion into the far infrared. Or, it could mean the galaxy is filled with thick clouds of dust, which absorb blue light and allow only the red light to pass through, much like how dust in Earth's atmosphere creates a red sunset. Often, these red galaxies are sites of intense star formation, or they may host a bright, active galactic nucleus at their core. They are the busy, dusty factories of the cosmos. Recent discoveries in nearby primitive galaxies like Sextans A are helping us understand this dust. Webb has found that even in galaxies with very few heavy elements, similar to those in the early universe, complex organic molecules and rare types of iron-based dust can form. This tells us that the building blocks for stars, and even planets, were being created in hidden, dusty pockets from the universe's earliest moments. Finally, let your attention settle on the smallest, faintest points of light, those that appear as tiny, greenish-white specks. These are often the most distant travelers. They are the ghosts on the edge of our vision, galaxies so far away that their redshift is extreme. Their light, which may have started as brilliant ultraviolet or blue, has been stretched across the entire spectrum during its 13 billion-year journey, so that its peak brightness now falls squarely in the mid-infrared wavelengths that we color as green and white. Each one is a message in a bottle from the cosmic dawn. Drift slowly from color to color, from the cool blues to the warm reds to the pale, ethereal greens. Each color is a different note in a grand cosmic symphony. You don't need to hold on to the details. Just allow the colors and their meanings to wash over you, painting a rich and complex picture of the universe in your mind. A universe of fire and ice, dust and stars, youth and old age, all existing at once in this single, silent frame. As we journey through this sea of ancient galaxies, let's now turn our attention to their very hearts. At the center of almost every large galaxy, including our own Milky Way, lies a sleeping giant, a supermassive black hole. For most of a galaxy's life, this central black hole is quiet. But in the early, chaotic universe, these giants were often awake and feeding. When vast amounts of gas and dust spiral into a supermassive black hole, the material heats up to incredible temperatures, creating a core that can outshine all the billions of stars in the host galaxy combined. This furiously bright region is called an active galactic nucleus, or AN. In the deep field images, these active nuclei often appear as intensely bright, point-like centers. However, in the dusty, crowded environment of the early universe, many of these growing black holes were hidden from view, shrouded by the very gas and dust that fueled them. They were invisible to telescopes like Hubble, which see primarily in visible light, but Webb, with its infrared vision, can peer through the dust. Just as infrared can see through smoke on Earth, Webb can see through cosmic dust clouds to witness these hidden black holes in the act of growing. Webb is revealing that actively growing supermassive black holes were already present, and perhaps more prevalent than once thought, even just 500 to 700 million years after the Big Bang. Instead of thinking of them as destructive monsters, let's reframe our perspective. Think of them as the silent engines of their galaxies. Their immense gravity acts as an anchor, the seed around which the entire galaxy may form. The energy they release as they feed can push gas around, either triggering new waves of star formation or blowing the gas away and shutting it down. They aren't just passive objects, they are active sculptors, shaping the evolution of their host galaxies over billions of years. Imagine these massive, silent anchors, one at the center of each glowing island of light. They are the quiet, invisible hearts of the cosmos. Their presence felt not through light, but through the gentle, inexorable pull of their gravity. They're a fundamental part of the cosmic ecosystem, a deep, quiet presence at the center of it all. Feel that deep, quiet, anchoring presence within yourself, a point of stillness and calm at your very core as you continue to drift peacefully. As our knowledge of the universe deepens, it doesn't always get simpler. With a clearer view come new, more subtle questions. The universe, it seems, enjoys presenting us with gentle puzzles to contemplate. One of the most profound puzzles in cosmology today is something called the Hubble tension. It sounds dramatic, but it's a quiet, persistent whisper of a question. The puzzle is this: we have two excellent ways of measuring how fast the universe is expanding, and they don't quite agree. One method involves looking at the very early universe. By studying the faint, leftover glow from the Big Bang, called the cosmic microwave background, scientists can calculate the expansion rate of the young cosmos. This gives us one number. The other method involves looking at the nearby, more modern universe. By measuring the distances to certain types of stars and exploding stars in nearby galaxies, astronomers can measure the current expansion rate directly. This gives us a different number, one that is slightly, but significantly, faster. It's as if we listened to a recording of a baby's first words and predicted how fast they would be talking as an adult, only to find that, as an adult, they are speaking just a little faster than our prediction. Why is there a mismatch? Is our understanding of the early universe incomplete? Is there something about the adult universe we don't yet know? Or could our measurements be off? This is where the James Webb Space Telescope can help. By using its sharp vision to make more precise measurements of stars in distant galaxies, Webb is helping to refine the local measurement of the expansion rate. It is providing a crucial new piece of this grand cosmic puzzle, helping us build a more complete picture of our cosmic history. There is no need for you to feel any tension from this puzzle. Instead, think of it as a sign of a healthy and vibrant science. The universe isn't a solved equation. It's a living, breathing mystery that is slowly revealing itself to us. It has secrets that it holds back, inviting us to look closer, to think deeper, and to wonder more. Embrace that sense of wonder, the feeling that not everything is known, that there are still beautiful, grand questions waiting to be answered. Let your mind be at peace with the unknown, finding comfort in the journey of discovery itself as you drift further and further into a state of deep and tranquil rest. Our long drift through space and time is now drawing to a close. We've journeyed from a familiar patch of sky, no bigger than a grain of sand, out to the very edges of the visible universe. We've floated past great clusters of galaxies, their gravity bending light and time. We've watched ancient, ghostly arcs of light from the most distant galaxies dance before our eyes. We've traveled back more than 13 billion years on photons that have crossed the cosmos just to greet us tonight. We witnessed the cosmic dawn, seeing the first, clumpy, irregular galaxies flicker into existence. We've seen through clouds of dust to glimpse the silent, powerful black holes shaping their domains from the very beginning. And now, our journey brings us back. From the edge of time, we gently pull our focus back through the billions of years, past the infant galaxies, past the grand spirals, past the great clusters. We drift back towards our own cosmic neighborhood, towards our own galaxy, the Milky Way. We float back to our own solar system, a quiet haven in a vast spiral arm. Back to our beautiful blue and white world, a precious jewel in the cosmic dark. And back to this room, back to this moment, back to the gentle rhythm of your own breath. Feel the comforting weight of your body, resting securely. Feel the stillness of the air around you. All the vastness of space, all the billions of years of history, have led to this one simple, peaceful moment of rest. The universe is vast and ancient and filled with a fire and energy we can scarcely comprehend. But it is also silent and still and deeply peaceful. In its immense scale, our own worries can find their proper perspective. They are small and fleeting against the backdrop of cosmic time. Let that perspective bring you comfort. Let it bring you peace. You are a part of this grand cosmic story, a tiny, precious, and beautiful part. And now, it is time to rest. Allow the gentle sounds of space to carry you the rest of the way. There's nothing left to do but let go. Let go of the journey. Let go of the day, and drift into your own celestial dreamscape. If this journey has brought you peace, perhaps you'll join us again for another quiet exploration of the cosmos. You can subscribe to be notified of future voyages. And if you feel moved, you might share in the comments where in the world you're listening from tonight, joining a silent community of fellow stargazers, all resting under the same vast, beautiful sky. But for now, all that is left to do is rest. Sleep well.